So first, welcome, and for such a great and a bit rainy day. But it's nice to see all of you here. And this is the science jam. Actually, it's organized by our young researchers. But unfortunately, today that's this chair that's not available there in the conference. That's why I take over to host this science jam. So science jam is also the opportunity or the platform for people to get to know our own researchers, because usually we have this lunch meeting series. Usually we invite people outside university. So today we're very nice to have Dr. Els Weinans here. And actually, Els started the assistant professor at Copernicus Institute since last year, November. And at the beginning of this year, we already received the application from her. Said, I heard about this complex system center, and it seems a really great place to be here. So that's why I have her application. So the daily board of the CCSF actually quite impressed about her application. So, and she did her PhD at Wageningen University on the time series analyzed for complex systems. So it's really close to what we are doing, with a focus on resilience and the complexity quantification tools. After that, she did a postdoc at Eindhoven University on uncertainty analysis in social simulations. So her current research is mostly lies on the intersections of mathematics, environmental science, and computational social science. So this is really very interdisciplinary. That's also what we really want to hear from our own researchers about their research. So Laura is yours.
Yeah, thank you very much. And yeah, so thanks for inviting me, and thank you all for being here today to listen to my talk. Yeah, so today I would like to talk about this topic. So what can ecological spatial temporal indicators tell us about the resilience of countries to economic crisis? So it's a long title, but I hope that as we progress through this talk, it will become clear for everyone. So this is a project that I did together with Maria, Roberto, and George. And Maria and George are both at Wageningen University, and Roberto is at Bologna University. And what I really like with this collaboration is that Maria and Roberto are both economists, and George is an applied mathematician, and I'm not sure what I am, but sometimes an applied mathematician or sometimes an environmental scientist. So we are quite an interdisciplinary group, and it's really fun because I'm learning quite a lot from them, and I hope they are also learning a bit from me. So it's a really fun experience for me.
Sorry, I was recognized your screen of road. That's in the rooms that I probably have to reach there.
Okay.
Yeah, no,
yeah. Okay. So first, I think it's good if I define resilience a little bit, because different people define it in different ways. So what I had in mind when I started this project, when I talk about resilience, is that I see something like this figure. And what we see in this figure is that there is a driver and a response in a system. So when we talk about the economy, the driver could be some policies in the organization of a country. And then the response is how well is the economy doing. So basically there are two stable equilibria in this figure. So the top line, let's say it's a healthy economy, so it's what we would like to have. And the lower line is an unhealthy economy. And then you can see that when the driver is somewhere in the middle, then you can be in both the unhealthy but also in the healthy economy state. And then let's assume we are in the healthy state and we are now lowering the driver, so we are changing some policies in the country. Then at a certain point, the healthy economy ceases to exist, it's not present anymore, and then the system will collapse into the unhealthy state. And then if you want to go back to the healthy state, that's quite difficult, because if you just reverse the driver to a little bit before the shift, then you're kind of stuck in this unhealthy state where you do not want to be. So then you have to either move all the way back to this other tipping point that you see over here, or you have to push the system upwards so that it's over the dotted line so that it can reach the healthy state again. And that is sometimes just impossible or very difficult to do. So I think everybody agrees that it's better to just avoid the tipping point altogether and not first push over it and then try to reverse that. So in the last decades, in a lot of different studies, people have looked for indicators that can tell us when such a tipping point is coming up. And most of these indicators have been developed in the ecological literature. So that's also what we studied quite a lot for this project. And then what you can see is that when you're far from a tipping point, I generated an artificial time series here. And then what you can see is that the dynamics are quite bounded, the variance is low, and you also see that it looks almost like a random signal. So there's not, the next point in time does not really relate to the previous point in time. And here I generated a time series very close to the tipping point, and then you see that the variance is a lot larger, right? The maximum and the minimum are a lot larger. And also you see that there's some memory in the system. So the next point in time relates a little bit to the current point in time. So there is some sort of pattern or slowness in the dynamics. So because of this, the most popular indicators of resilience are this increase in variance and increase in autocorrelation, and they can then tell you when you are approaching a tipping point. So there we go. So we first tried to apply these indicators to unemployment data that we had for France. So here in the top panel, you see the unemployment data on a national level. So this averaged over all of France. And then we calculated the autocorrelation and variance. And the little boxes that you see, those are the moments that are indicated as crisis moments. So that's not based on this time series, but that's expert knowledge that we put on top of the time series. So the economists can tell us that those are moments of crisis, and then we want to use this autocorrelation and variance to predict when those crises occur. And based on the line for autocorrelation and variance, I would say that nothing really is going on. They do not really seem to be good predictors. So for variance, we see that there are some peaks after the crisis moments, but even that doesn't happen for the first one. And that's probably related that the whole crisis moment is included in the analysis in the moving window, so that if you see any large deviations that you see here or here, then there, of course, the variance is temporarily a little bit higher. But in general, we concluded that this is not a good approach. So then we decided to look at a different scale. So here we looked at a NUTS 3 level. So that's for every department in France. And France has 96 departments. So these are 96 lines that show you the unemployment in all the different departments of France. And what is nice about the data that we have here is that we can plot it on a map. So here I show you two examples. So this one is for 1990. So that's what you see over here. And there you see that overall the unemployment is quite low. So it was going relatively well compared with some other moments in time. You also see that in the north and in the south, the unemployment is a little bit higher. Yeah, I think that's the most striking thing we see here. And this is a graph for 2013, so that's over here. And then you see that in general, the unemployment is a little bit higher everywhere. Still, the north and the south, they suffer quite a bit from this. You also see that the Paris region over here is popping up. So there also unemployment is high. So with an analysis like this, you can do, you can take into account the spatial organization of the different departments. So we use two methods that to try to unravel what exactly is going on and to see if we can find some indicator of the crisis moments. So we use the principal component analysis and we use Moran's I. And I will first explain a little bit about the intuition between both methods, and then after that I will show you the results. So for a principal component analysis, I'm going to give you an example with only 2 time series. So let's assume you have only 2 departments in France, because that helps for the visualization. And then if you have 2 time series, let's say for region A and region B, then you can make a scatter plot out of that. And that's nothing new, people do that sometimes. So every point in the scatter plot represents that at a certain point in time, region A has a certain unemployment level and region B also has a certain unemployment level. And that's what the plot represents. And then if I remember the time indices of all the different points in the scatter plot, then of course I can retrieve my time series. So if I do not have this time series, but I have the scatter plot, and I know that this is the first point, this is the second point, the third point, then I can look what is the value of this point onto this horizontal line, and then I have the first point for my time series. And for the second point, I can get the second point of the time series. So if I have the time indices, I can retrieve the time series for the first region and also for the second region by looking at what happens at the vertical line. And in this graph, I hope it's kind of intuitive that there's not really a reason that only this vertical or horizontal line are the interesting lines. Because those were the 2 things that I could measure, so that's why I started with them, but they might not have the most interesting information. So I can do this trick for any line in this scatter plot. So I'm just picking a random line here. And then I can look what is the behavior of those points onto this new line. So I project the data points onto the new line. And so it's a linear combination of the 2 input lines. And then I can create a new time series. And the nice thing of the new time series is that it can contain information that is really different from the original time series. So if I then calculate the autocorrelation or the variance, it doesn't have to be the average of the 2 input time series. So here the autocorrelation of the first 2 time series are about 0.5, and the new one has an autocorrelation of about 0.6. So you see that it's not the average, it tells you something new. And then in this 2-dimensional case, you could just try it for all the possible directions, but of course in a 96-dimensional space that gets computationally quite expensive. So there we could just do a principal component analysis, and that immediately gives you the direction of the highest variance. That's exactly what the principal component analysis does. And we expect that the direction of the highest variance also gives us some information of which regions or which departments in France are kind of dominating the unemployment signal. Yeah. So now for Moran's I. Moran's I is a measure that can tell you something about the clustering of a spatial system. So here I generated two different spatial structures to give you some intuition. And here on the left, you see a high Moran's I, so there's a high level of clustering, because the black dots are kind of together and the white dots are also close together. And on the right side, it's randomly distributed, so it has a low Moran's I. And we thought this would be interesting in our unemployment analysis, because if I'm now living in a department where there's very high unemployment, but in an adjacent department there is low unemployment, then I could just find a job there. Maybe I have to travel for 1 or 2 hours, but I could find a job there. But if the regions with high unemployment are clustered together, then it's a lot more problematic to find a job somewhere. So we expect that if the system is more structured like this, then to get out of the crisis, you really need a large systemic change to either build a completely new industry or people have to migrate to different places. So that can be problematic when you think about unemployment. Whereas in this situation, we expect that things are better. So there can be high unemployment in one region, but the rest of the system can kind of control for that. So we did this analysis for our regional unemployment data of France. So the top panel is the same data as I showed you before. And now the second panel are the coefficients of the first principal component. So that's basically the direction of this new line that I created. And it's a bit hard to see, of course, or interpret in a figure like this, but later I will also show you the graphs so that you can see it, how it looks like in France. But for now, I would like to first draw your attention to the explained variance, because the explained variance will tell us, so we find this direction of the highest variance, and then if that variance is really a lot higher than all the other variances in the system, then the explained variance is high. So that basically means that all the dynamics that you see are really happening along that line that we just found. Whereas if the explained variance is low, that means that the dynamics are kind of everywhere. In a completely random system, you'll expect a low explained variance. And what we see is that every time after a crisis, there's a kind of drop in the explained variance. And you see that that coincides with a reshuffling of the coefficients of the first principal component. So the way that we interpret it is that during a crisis, there is something happening in the system, and the regions that dominate the dynamics before the crisis, they become less important during the crisis, maybe because the industries change or some factories collapse or things like that. And then those regions become less important, and then at some point other regions take over the dominant direction or the dominant dynamics that we see, and that's the reshuffling that we observe in those places. Yeah, so here you see some more information, and I focused here on the 2008 crisis because I think it was the more recent one that we maybe all remember a bit better. So the unemployment data, the left graph is during the crisis, the right one is immediately after the crisis. And you see that in general, the unemployment increased everywhere. And again, the north and the south suffer the most. But for the principal component analysis, we see that at first, the dominant change is, or the dominant dynamics are occurring here in the south. So that means that the tourism industry might have played a role there. Whereas after the crisis, we see that the regions here, that's kind of bordering southern Germany and the border of Switzerland, and they are dominating the dynamics there. And this area represents the heavy industry and heavy manufacturing. So it has a very specific target. About 20% of the people who live there work in the heavy manufacturing. So in that sense, it's not very diverse in the job market that it offers. And apparently this region led the dynamics after the crisis. So the unemployment was either a lot higher here or it was more correlated with other regions, and those regions became important. And I think, or what I like from this graph is that it gives us some regions to focus our attention on that you do not find just from the raw unemployment data, because those are not necessarily the regions with the highest unemployment, as you see in the top, but they are dominating the signal. So that's it for the first two graphs. So that's it for the principal components analysis. Then for the Moran's I, so that's a level of clustering, where we expect that a high level of clustering is bad for the system. And then just by eyeballing, I thought I could see some increase before the crisis moments. But of course, it's good to also do some statistics, because my eyeballing is sometimes also a bit wishful thinking. So I used the methods that's also used in some other papers, also in the ecological literature mostly. And here the black line is again the Moran's I, so the level of clustering in the different years. And the red, the dashed line, is the mean of a 3-year window, plus the standard deviation of the 3-year window. And then I say that there is a warning signal, so the yellow areas are warnings, when the red line is above, or the black line is above the red line. So the current value of Moran's I is higher than the mean plus the standard deviation. And also The trend of the line, I calculate with a Kendall's tau, so the trend has to be significant and higher than a certain cutoff value. So I did that to make sure that when, let's see, there are some areas where also the black line is above the red line, but there's not such a clear trend, and I did not want everything to pop up there. So those were the 3 criteria that we used. And then we find 3 different periods where there's a warning signal based on these criteria. And you see that they are aligning quite well with the crisis moments. And what I thought was especially nice is that we see no warnings in places where there is no crisis, because those indicators are notoriously bad because of the number of false positives that they give. So that the warning, you get a warning even though there's not a crisis moment. But here we really only see the warning when there also is a crisis. Of course, I just explained you the criteria, and there were some kind of arbitrary choices that I had to make there. So I also did some sensitivity tests, and I can also show that later at the end of the slide deck. I have some, I can show you the sensitivity test. And of course, you can break it down. If you tune the parameters in such a way, then you do not get warnings anymore, or you get some false positives. So the way that I think we can explain this is based on the resilience mechanisms. So the spatial variation in the different regions, but also the response diversity, as they call it, and also in the ecological literature, that means that different species in the ecosystem can kind of take over the role of another species. So if we apply that theory to the economic system, that means that if you maybe lose a job in one area, not in one area, but in one field, then you can transfer to a slightly different field. And also the spatial variation that we talked about before, we think those are the important mechanisms here. But kind of at the end of the project, I also started to think again about this tipping point figure that I started with. And I think we might have to move away from that a little bit, because you don't actually need it in this storyline. So the tipping point figure helped us to come up with the ideas for autocorrelation and variance in the morals eye. But I'm actually not so convinced that those crises are really manifestations of clear tipping points, or if it's more, just with the explanation of these spatial interactions, you can explain the full story. So you don't actually need this tipping point theory. We're still struggling with that a little bit, because I can also not really prove that they are not tipping points, but I can also not prove that there are tipping points. So I think we have to be a little bit careful with that. And also what was kind of unexpected in a way was this reorganization after the crisis, that we can also match quite well to the literature, so that they have been manufacturing really struggled after the crisis, but it did not pop up in the absolute unemployment rates, but then it did show an indicator with the principal component analysis. So we thought that was kind of neat that the analysis revealed this property. So this is still a work in progress. So we hope to submit this somewhere the next month, maybe. So if you have any ideas or feedback, then I would be very happy to hear it. Or if you have any questions, then of course I would be happy to answer that.
So okay, let's do we have interaction, just ask the questions in between.
Yeah.
Yeah. Actually, I have one question.
Yeah.
Yeah, if you go back to this, the Morris eye, that's the issue. There's a trend of going up. Probably yes. Yeah, because this is here 2019, right? So if you see that's the actually it's also a trend going up. Have you tested that's for the data later on? Because now you have 3 more years data. Whether you can see this is also a crisis coming.
Yeah, it's a good question, but we didn't try. So it was quite difficult to get the data actually on this level. So the national data is just updated yearly and accessible to everyone. But this data we got from a friend who's working in France on this topic. So yeah, we don't have it for after 2019, unfortunately.
Okay. How are you going to interpret this? Is also going up trends?
This last one.
Yeah.
Yeah, so I ran the whole analysis also for that part, and we see that the black line is above the red line. So apparently either the trend is not strong enough or the p-value is not lower than 0.05, because those were my other two criteria. Yeah, so the trend there is less strong than in the other moments.
Okay. Is this window really matters because you see this?
Yeah, I can actually show that also. Yeah, so this is the sensitivity test for the window size. So the window size of 3 years we chose as the kind of default. And then if we increase it to 4 years, we see that the moments become a bit more narrow and also a bit later. So you miss some of the crisis or only give a warning when the crisis is already happening, which is not so informative, of course. And then if you decrease it, then you get more false positives. But then actually the later region is also popping up, so maybe that's not a false positive. It's a bit hard to say, of course. Yeah, so there is some sensitivity.
And maybe a clarification question. You took as ground truth data for crisis, the expert judgment.
Yeah. Yeah.
Would you, if you would show slide number 9 again, please. We see a sort of crossover point around 1994, but there was no crisis. But that is a very low explained variance round. So how does that fit in your model?
Yeah, so I'm matching that to the 1990 crisis. But maybe it's too late for that.
Because you have a sample size now of 3, of which 1 is questionable, right? It's a bit...
Yes.
Yeah.
Yeah. So there are some things that maybe make it a little bit better or maybe make it worse. I don't know.
Yeah.
But
you're taking it's like you're taking the first derivative of the explained variance as the explained variances itself.
yeah, and there is also some discussion about the exact moments of the crisis, of course. So there are also some people that say that the 1990 crisis lasted until 1993, and then we would be okay with this moment.
It would not be a predictor, it would then be a symptom.
Ah, yes, definitely. The reshuffling is happening always after the crisis. So the reshuffling of the PCA and the explained variance I'm not using as a predictor here.
The AI research that I have been recently reading, a lot of emphasis is being put on explainable AI. Is there a hint of an explanation here? Do you have an explanation on why this would be an indicator?
The explained variance.
Why the Moran's eye, which you said was why the Moran's eye would be a good indicator?
Yeah, so the explanation that I like the best is what I kind of stressed in the presentation, that when the level of clustering is very high, then that makes it harder for people to deal with unemployment because they cannot track.
It's a fragility.
Yeah.
Thing.
Yes. But there is also in the ecological literature some hints that it can also link to critical slowing down. So that's what I told in the beginning, that this increase in variance and autocorrelation, if you make simple spatial models out of that, and you push them towards a tipping point, then you also see that there appears spatial clustering when you push a system to a tipping point. So there is, depending a little bit on who you ask, there is some intuition behind it. Yeah.
But the one set of opinions is one way in one directional, and the other goes in the other direction.
Yeah, but I think they are not mutually exclusive. So I guess that part of this explanation of that the different regions, that if there is heterogeneity in space that you can travel more easily, that can go hand in hand with the idea that when the system slows down, there's more spatial clustering. But it's on another level, right? So then, according to some driver that we might not completely understand, the system is pushed into a way where there's more spatial clustering. And then because this leads to a harder time for people to find a new job somewhere else, this may lead to a crisis moment. Could be something like that.
No further.
Yeah, about your choice of the nudge level, I can imagine that the type of industry that pops up in your spatial autocorrelation very much depends on the nudge level that you choose. Because, for example, the tourism industry occurs along the whole coast, so it's a lot of large regions, and it's the same with the heavy manufacturing industry. Whereas other things like you also have within cities clusters of bakeries or so, but that's a way smaller scale, finer skill level, I should say. What's your reason for choosing this 3 level?
This was the smallest we could get.
Yeah.
So yeah, so larger didn't make a lot of sense to us.
Yeah.
The smaller would have been interesting.
Mhm.
But I also think on a national level, this space kind of makes sense for the overall industries in a country. So the bakery example that you give, that's more a city dynamic. So maybe
Yeah,
if
exactly.
you really want to know something about Paris, that might be interesting.
Mhm.
But on a country level, I think this makes sense. And also we have net 3 data for Switzerland and Spain, so we also repeated the analysis there. There was a bit of a problem because they have a lot less so cantons or regions, and so cantons in Switzerland. So then the statistical power becomes a lot smaller.
Yeah, but it also depends on what type of industry was affected by the crisis. Because, for example, the IT industry can be very scattered, especially.
Yes.
Because it doesn't really depend on environmental characteristics where you place that industry.
Yeah.
I have a follow-up question. Basically, because many of the people studying economic resilience, they would look at the structure, industry structure or occupational structure of regions. So because different regions will respond to same crisis differently because they have different structure. So then the unemployment rate at the regional level within the region will differ across different kind of industries, occupations within the region. So I was wondering how this kind of model can incorporate that type of indicators, because you touched upon this when you are explaining the spatial variance later as the main variance. But then my question would be like, because many of the variants are really driven by the initial structure, how you incorporate that in the model. I have a second question, is like, because
Shall I do first your first, otherwise?
yeah, sure. Yeah.
Yeah, I do not have a very satisfying answer, I'm afraid, because like the differentiation within one department, we are not putting that information into this data, so we are also not using it. So that's more on an explanation level that we try to look like, hey, how many people were working in which industries, and then afterwards we try to explain what we see. So that's more the expert knowledge, but not in the data we do not include that.
Yeah, the second one is because sometimes in a response to crisis, not only high unemployment rate, also you could also look at employment growth. So would be another way to look at how regions respond to crisis. Because many people would argue it depends on what type of crisis the region might respond differently. So it's just like using a different indicator to see whether this has the same pattern.
And then with an employment growth, do you mean just the difference in an employment rate?
Yeah, because unemployment rate and the total number of jobs, they capture different aspects of the labor market. So I think it'd be interesting to look at different aspects.
Yeah, that makes sense. Thanks.
Yeah, so for side notes, also in Faculty of Geoscience, so we are in an economic geography group. So we applied this kind of complexity to indicator to study economic dynamics of regions and countries a lot. So it's we can catch up later.
Yeah, sure. Yeah, nice.
Could you explain to me this tipping point theory you mentioned shortly? Because you said you're not sure how to incorporate it in your paper yet.
So that was kind of the starting point of our analysis.
Yeah.
Was this idea that an economic crisis is a kind of manifestation of such a tipping point, so that you go from a healthy economic state and then you tip into the unhealthy state. And that then when you recover, you are kind of pushing a driver all the way back. So you're doing some restructuring of your country, and that drives it back, and then you can get back to a healthy economic situation. So that was our first kind of metaphor to think about the economic crisis when we started talking to each other. And that's also why we came up with the PCA and the Moran's eye, because in models that are modeling these tipping points, they see that as you are moving close to the tipping point, Moran's eye will increase, and principal component analysis can tell you a little bit about which regions are responsible for that. So it was our starting point, and that's why I thought it was important to include it here. But I think at the end, we don't actually need this anymore to explain what we see.
Because why would you doubt to include it in your explanation?
Yeah, because it also feels a bit strong to say that we are seeing tipping points where I actually don't have any proof that these are really tipping points.
Yeah.
I'm not sure that this is the mathematics that's underlying what we see.
Yeah, okay.
And that's mostly because in the time series of the unemployment data, I don't see such clear jumps up and down. It's more kind of fluctuating all the time. So based on this, I'm also not so convinced that
there's not really clearly one kind of correct. Yeah, no. I also don't know exactly what would be the nature of this crisis. Like, so yeah, to the crisis, I don't know exactly what are. But it's that's an expert panel that decided that. Then
yes. Yeah. So the 2008 crisis.
Yeah, that's quite widely acknowledged.
At least that one is in there. Yeah.
But you can find that crisis in many time series, like employment, housing crisis, all the.
Yeah.
Yeah, I had a question about your Moran's eye indicator, which seems to be having also a trend, an increase in trend. And do you understand why?
Yeah, so that means that the clustering overall is increasing. And I'm not sure why, no. But that is why I wanted to have these additional criteria to say when something is a tipping point, otherwise you'll get a lot of false positives, of course. Yeah, but we don't have a good explanation for that.
Also, why 1986 would be the year of total randomness of distribution of this indicator. But what happened then, or just before it, or what happened afterwards? I mean, France has been a centralized state for over 2 centuries, so.
Yeah, so I can plot the maps for different regions, and then you can see a little bit more why or which regions are have high and low unemployment.
Yeah, but this was more regarding to what that the tendency of Moran's eye seems to be up.
Yeah.
And that only took that took less than 30 years. Like,
so it could be that it is more easy to travel from one department to the other, something like that. So I was thinking about it, those kind of
when did they start building the TGV?
those kind of
in the past, the industries were a lot more related to where you were living exactly, of course, and now with more technology, people are also working from home, or it doesn't matter as much anymore where you live.
So it might be a trend that stuff is following now the population clusters, whilst usually it used to be geographic clusters. Because many indicators are just a heat map of where people live, at least geospatially.
Yeah, and the second point, is it also that you have seasonality in your unemployment data, or is part yearly data?
So this is quarterly, so every 3 months.
Okay.
And we don't see a strong seasonal signal here.
Okay, because you also have tried to find that out. So
Yeah.
Well, for the tourist industry, all those kind of issues, of course, those are seasonal related.
Yeah.
But you do not see any.
No, so you do see some wiggles, of course,
Yeah.
but it's not exactly the seasonal
Okay.
pattern. It was not so clear.
Yeah.
No.
Okay, good. Yeah.
So just a quick follow-up on that, I'm assuming I don't know the Moran's eye at all as a measure, but presumably it runs from 0 to 1.
Yes.
Right, so, okay, so that what we see as the absolute value in 1986 is relatively speaking for this time period, rather than really being.
Yeah, so it's all between 0.1 and 0.3, so
Yeah.
the difference is not as extreme as when it would be from 0 to 1.
If a cluster, you now mentioning cluster as a driver of the tipping point, or not the tipping point of the crisis. But if then one's eye is increasing over time, should you then not predict more crises over time?
Yeah, so it depends a little bit on when you then give the warning signal.
Not
So-
really, because if the clustering is the driver.
No,
Then
it's
the
the difference
clustering,
in clustering that is the driver. So it's
Yeah.
the increase in clustering.
no, that's the signal.
I agree with you that in my mechanism, it would make sense that there are a lot more crises in the, if that were the only explanation for the crisis, you would expect to see more crises when the Moran's eye is higher. So it's not the full explanation, definitely, also because the economic system is more complex than that. Yeah, and there also, we are not sure exactly what's going on, but I think there it could also relate a little bit to just the overall changes in the industries. Like we said before, the overall trend. If we could link that to that, the industries are just changing in general. And people are working more in technology and less in heavy industry, so less regional dependent in their jobs. That can make up a little bit for this increase in trend that we see.
Or just urbanization, metropolitan area become bigger, and then the difference between metropolitan area and other regions are increasing.
Yeah.
Yep.
Yeah.
So that's right now you only like if you show the picture of the alternative stable states, it's only in 2 dimensions, but of course you can also have different drivers that are working together. And then just one thing like the Moran's eye is not enough, it's not sufficient to show you what is actually going on. You know, I mean the first one, the alternative stable states. Yeah, that one. So now you have only one driver, but of course there are many other different drivers.
Yeah.
So you can have different responses in different alternative stable states.
Yeah, definitely. And also in the system with a 96-dimensional space, it's very likely that there are more than just 2 stable equilibria. So that also the tipping point is not such a clean jump from one state into the other, but it's more messy. So that's also, of course, what we see in the data, that we cannot distinguish these states from each other, and definitely not just 2 of them. So
I was wondering then that how do they actually define the conditions for when there is a crisis? So did it also change over time, or are these all similar between different crises?
That's actually a good point. And I'm not 100% sure. I should ask the economist that are also working on the paper, because they also gave me the dates that I put on here. I think in the economic literature there is quite some agreement, not exactly on the start and the end of this crisis, but that there are crises around 1990, around 2000 and around 2008. There's not a lot of discussion about that, if I understood correctly. But of course there are different processes in the different cases. So for the 2008 one, it didn't start in France, for example. So there, you could also, maybe it's a bit weird if you actually see a signal also starting in France, because that was not where the crisis originated from. Whereas in the 2000 crisis, there was more also in Europe responsible for that, if I'm not mistaken.
Because what we like called a crisis in the 1990s, maybe we're just used to it right now. So it's constantly living in a crisis, but we don't know it.
A crisis is when GDP per capita is falling for more than 3 months. So it depends also per country, but in the EU, it's like the GDP per capita is really falling through time.
So
So
we're
it- it's
already
the same.
like below somewhere and you can't fall anymore.
Yeah, but let's say the definition is the same.
Yeah.
Throughout.
Okay, good.
Thanks.
My understanding for ecological resilience is the ability to absorb a crisis. And I want to know, how do you explain that based on your data and the methods?
Yeah, so I think for that definition, this figure helps me a bit. So I wouldn't say the capacity to deal with a crisis, because here we expect that the crisis is already the jump outside of your equilibrium. But I've heard that then resilience as a definition is the capacity to deal with perturbations. Is that also okay for you? So then if I look at the system far away from the tipping point, so in this situation, there, if I perturb it a little bit, you can see that at like the next point in time, or maybe after a couple of days, you do not really see that signal anymore because the dynamics are so fast. So then the perturbation is kind of lost in the signal and it's absorbed. So in that sense, this system can deal with perturbations very well. Whereas in this case, if I perturb the system over here, then you see that still after quite some time steps, you still see a fingerprint of the perturbation in the system. So the capacity of the system to deal with this perturbation is not as good. Does that help? Okay. Okay.
So the definition of quantitation?
Yeah.
Okay, great. First times.
Thank you very much for coming here.